Chapter 6, Section 4, Part 2. Still working on factoring. This time, we are going to factor ax squared plus bx plus c, but a is going to be greater than 1. So it is not going to be the same as when we just had x squared plus bx plus c. So in this, again, first step when factoring, always check for that greatest common factor. So I have 18, 75, and 72. My greatest common factor there is going to be 3. So I'm going to factor out a 3. 18 divided by 3 is 6, so 6r squared. Plus 75 divided by 3 is 25. And 72 divided by 3 is 24. So now I have a number here. Since I have a number here, I'm going to do the a times c method. So I'm going to take a times c. So we're going to take 6 times 24. 6 times 24 is going to give me 144. That now becomes my new number that I need to find factors of that will add to 25. So we have 8 and 18, 12 and 12, 2 and 72 is 1. Three and 48, 4 and 36, 6 and 24, and 9 and 16. So if I look here, 9 and 16 are going to give me 25. So once I find those factors, I'm going to split and make this trinomial have 4 terms. So again, that 3 is just going to hang out. We'll have 6r squared plus 9r plus 16r plus 24. I then have 4 terms. That means we're going to factor by grouping. So again, 2 different groups. Greatest common factor out of each group. So I have 3 on the outside, 6r squared and 9r. I'm going to factor out a 3r. And I will have 2r plus 3. 16r and 24. I'm going to factor out a 4 of, I'm going to factor out an 8. I'll have 2r plus 3. So then, parentheses are the same. 3 is going to hang on the outside. We have that 2r plus 3. I'm factoring that out. And then we have what's left, which is 3r plus 8. Okay. And you're probably thinking, well, Miss McAllister, 8 and 3 is 24. Why didn't we just do it the normal way? Well, that's called the guess and check method. It could take you forever because the reason why we do the A and C method is because of this number in the front. It's not a prime number. If it is, you could just have, like, if it was a 5, it would just be 5R and R. Or if it was just 1, we had an X and an X. But since this number has multiple factors, it is best to go ahead and factor it out using the A and C method. Sometimes it takes a little longer, as you see, to get that added number. But once you have it, everything falls right into place. So with that 6R squared, we could have had 2R and 3R, or we could have had 6 and 1. So you would have had to try all of your factors for both A and C instead of just going ahead and factoring by grouping and taking it by there. So let's try this other one. 4m squared plus 8m minus 21. I'm going to check for greatest common factor first. 4m squared plus 8m minus 21. There is nothing that divides into 4, 8, and 21 evenly. So I'm going to take A times C. So 4 times 21 is going to give me 84. 84 now becomes my number that I need to find my factors of that will add to 8. So we have 2 and 42. We have 3 and 28. We have 4 and 21. We have 6 and 14. So if we look, and technically this is negative 84. If we look, 6 and 14 is going to give me negative 84 if one of them is negative. So in order to get 8 out of 14 and 6, my 6 has to be negative. So again, we're now going to expand. We'll have 4m squared minus 6m plus 14m minus 21. Again, I want to factor by grouping. Greatest common factor here is going to be 2m, and that will leave me with 2m minus 3. Over here, I'm going to factor out a 7, and I will be left with 2m minus 3. Parentheses are the same. 2m minus 3 is going to be factored out. 2m plus 7 is left. So that is factoring when your A is not a prime number, it's greater than 1. You have multiple choices for that A when it comes to factors. A times C method. The last type of polynomial to be factored is ones that are special cases. So you have the difference of squares and you have perfect square trinomials. Difference of squares is when both of your terms are perfect squares. So if it was x squared and 9, or x squared and 16, or 4x squared and 25, these two numbers have to be perfect squares. If they are and they're being subtracted, difference of squares gets the name easily, you're going to automatically factor down into this. You're going to have pretty much the square root of A in both of those spots, and then the square root of B, and then one's going to be plus, one's going to be minus. Those are good. That's going to be the form every single time with these. So if we look at 25p squared minus 4, Be like, okay, well, there's two numbers. It's a binomial. I can't factor anything out. There's no greatest common factor. It must be one of those special cases. 25 is a perfect square. The square root of 25p squared is 5p. Square root of 25 is 5. Square root of p squared is p. The square root of 4 is 2. So this is going to factor down into 5p minus 2 times 5p plus 2. And that's it. You're done. So over here, x squared is a perfect square. So is 1. I'm going to factor that down. X minus 1, x plus 1. So square root of 1 is 1. Square root of x squared is x. You also have perfect square trinomials. Now this is when you have 3 terms. Your first term has to be a perfect square. Your last term has to be a perfect square. The middle doesn't really matter. All we're pulling from that middle number is if it's positive or negative when we go to factor this. And this should have a square. So it should be a plus or minus c squared. So if we look here at a part C, 4n squared plus 12n plus 9. 4n squared is a perfect square. It comes down to 2n. 9 is a perfect square. It becomes a 3 when you take the square root. And since this middle term is plus, we're going to drag that down. So 2n plus 3 squared will give us that trinomial. Same thing here. I have 16x squared plus 24 plus 9. 16x squared is a perfect square. It drops down to 4x. 9 is a perfect square. It becomes a 3. Plus sign gets carried down. Close your parenthesis and square it. And that covers everything in factoring for when you can factor polynomials. Homework for this lesson is Chapter 6, Section 4 worksheet, Part 2.